Very good morning to everyone. As part of continuous improvement, we integrated RabbitMQ server with Python CAN library. What is Python CAN library? Python CAN library from Hardbyte is the widely used Python library in automotive industry for exchanging packet in between real hardwares and the Python, right? They also support wide variety of hardware vendors, can network analysis hardware vendors. Those are available in the market right now. You can find Python can hardbyte Python can library from this URL. So here it is, right? It is from hardbyte, right? This is the one who developed or one who started developing this Python can library right now. It support most of the network analysis hardware vendor that we have in the market. You can check that in their interface folder. These have support for ETAS, ICS, NeoVI, and then Kawasar, PCAN. These are the famous uh, network analysis hardware vendor that I know. And then finally, we have this network analysis tool vendor Giant Vector as well. They support the vector hardware as well. So you can buy CAN hardware from any one of these famous vendors and can drive their hardware using Python CAN library. You can exchange packet from the PC to your real hardware and you can get the packet from them as well. So you can exchange packet actually using their library. So it doesn't require any Keno or any other vendor-based GUIs. So you don't require any of their GUIs. Like with respect to vector, we don't need Keno. With respect to Pecan, they have their own GUI. Like that, without their GUI, you can drive their CAN hardware and can exchange the packet. That is the ultimate goal of developing this library. So it is see, when the software network analysis tool vendor has some sort of GUI, why we have to look for Python can? It is needed because Python has a lot of pre-written libraries, and the system testing engineer can up of a customized solution for their need right now. When you have to work with Keno or other GUI tools, those are available from different vendors. It need a learning curve. You have to learn a certain programming and how to work with that tool. But when it comes to when they support a Python-based interaction, the interactions initiated from Python in their hardwares, we can use a single language, single programming language that can work for different hardware vendors right now. So initially, we want to train people in this open source library. The limitation that we have in this library is it doesn't support inter-process communication. That means you have to transmit and receive your packets in a single module only. See, when it comes to network REST simulation, we used to have one program for one module. For let us assume I have 4 nodes in my network. For each network, I used to have an independent Python program, and they have to run independently. When I want to exchange packet in between them, that should be possible by this library. But the limitation with hardbyte Python can is they cannot exchange packets in between or information in between process that they already told in their documentation. If you have doubt, you can go there and can refer their documentation. Okay, now we want to create a dress simulation or a network completely using Python. For that, we try to use this Python CAN library because they already have a lot of standard library functions, and it is a working solution and support different famous hardware vendors. We got a very big challenge because they don't support inter-process communication. Then it is very hard for us to develop a module as per their design. So this was running in mind for a long time. After that, we started our research, and we tried to interact with RabbitMQ. We want to exchange the packet via a queuing server that is also an open source, which is available in the market, called RabbitMQ. The exchanging information via RabbitMQ in between programs require their own libraries. They require some sort of a Pika library and then Erlang language, all those things we require. We installed all those things. We exchange information between Python programs, and we conducted the training as well. Now the gap is the industry is using Python can library which follow a certain syntax to declare a packet and transmit the packet and receive the packet. But in our design, which is more elementary, which is doing in a different way. But the concept wise, at the end of the day, we have to exchange the packets in between nodes. When we want to do that completely in simulation level without any CAN hardware, if we don't have any CAN hardware, we want to do that in between everything in a software, everything in laptop right now. So for that only, we started a research. How can we integrate our currently successful implementation that we have via Python and RabbitMQ server. So we are able to exchange packet in between Python modules and can create a REST simulation, and we are able to demonstrate our REST simulation concept using that design. But we have a gap. So we have our own way of transmitting messages and receiving messages and all those things doesn't in line with the Python CAN standard. So now what we did, after a research, we developed our own interface for RabbitMQ that is based on, after going through their hardbyte Python CAN code. After a research, we come to know that, okay, this is possible. We can develop our own interface for RabbitMQ. See, in this hardbyte distribution, we don't have a interface called RabbitMQ that we developed now. So then we also made a necessary changes that is required for our implementation, and we come up with our library, which is based on hardbyte. So we didn't invent everything from the basics. We took hardbyte, we forked their code, and we added the RabbitMQ related information to that, and now it becomes our our customized library that can be that meets industry standard. So that is what that we achieved. For that, we have in our repository. Let me go to my repository. This is our repository. So this is the fork code that is forked from hardbyte Python can. So we took their code and customized their code for our need. That's all. To meet the industry standard. That is what we did here. Right now. So what we did, we added an interface for RabbitMQ in this library. Here it is. We have a RabbitMQ interface so that you can use the standard library function to do the exchanges via RabbitMQ right now. So after studying their code, it was it was very impressive experience. I learned how their code works, and then I modified their code to work for RabbitMQ. That's all. Right. So how to install this? You can install our library in Python. We have archived this in GitHub. It is there. So to install our library, you can use this command. That means our distribution python -m pip install within double quotes, because our library is not in PyPy. So Python hardbyte Python can is available in PyPy, so that you can install just Python -m pip install Python can, that you can do. But ours is a customized one. It is not in PyPy, right? So for that, you have to install it from source. For that need an additional commands like Python -m pip install, within double quotes you put git plus, then the path of our library, that is URL of our library, that you can take from here. So this is our repository, no? So Yahasia Python can, here we have code. So I took this path, SSH URL. No, I believe it's HTTPS URL. This one. I took this URL and I added that with git plus, and then you can install our library directly from GitHub to your Python installation. Right now, you can use it there onwards. So that much simple it is. Once you install the Python can, our Python can distribution, before doing it, you need a Git installed in your machine. I think without Git it won't work, because using Git they will fetch that one from the repository and then they will install. So to get Git, you can go here. I think here is a website link. So I can put these links in the videos, right? You can descriptions of videos. You can fetch from there. So git gitscm.com download win. So you can go there and can get it. So let me show the path. Right, from here you can get the required setup for your window, or for your OS bit size. According to that, you can get it and install. Once you install that, after you installing Python in your laptop by following the procedures that we explained before in other videos, that initial videos, so you can use this command in command line to install our library. Okay, now our library is installed. Now how to use it? So we have to test that whether our installation is correct, we are able to transmit the packets or not. For that, we have to develop a INI file in our current working directory. After installing the library in your Python working directory, you create a INI file. That INI file follow this structure, right? This is provided by Python Care, Python Can, Hotbyte Python Can library distributor. They have this format for INI files. Here, you have to give the interface as RabbitMQ, because it is we developed the interfaces for RabbitMQ, right? So you just give that name there, and then the channel is virtual channel, because we are not going to use a real hardware. We are going to use RabbitMQ as our hardware, right? After doing it, you just set your bitrate. So after setting this, your INI file should be there in your current working directory. This is the mandatory requirement. If you don't do that, nothing will work, right? So first step is we install the library, then we created an INI file and kept that in a current working directory. Then we have to write programs. We have to write programs to test that, right? So it's very simple. We have an example program here. I developed it. The hotbyte Python can library, in using that library, how they used to write no program in that way only, but we have some small changes. I will explain them. First, you import the can library, and then you import a JSON. This is for some sort of converting a message to strings and a string to message. In those areas we are using it. And then we have something called as a custom encoder, that is part of a bus module. We have included this function is included by us, custom encoder. And then we import everything from can library, That means Python can library, whatever the library that they have, we are getting all of them. Then we call like can, we import can.bus module from the can library, and we call that as bus, right? We create an instant. Then we import time as well. After doing it, you have to write a program by following the concept that is explained in their documentation, like hardbyte Python can distribution documentation. They have certain syntax to create programs. We have to follow it. So with can.bus, with can.bus as bus, right? This is the statement. This is the root main thread. In main thread, we are writing it with can.bus as bus, can.bus off as a bus. This is a function actually. So we create a bus. After creating a bus, we create a message. To create message in Python can, we have to put can.message, right? Can.message is a function name. And then I give an arbitration ID. You have to give an arbitration ID to your can packet. Then you have to feed your data, right? Here I have some data here. And then I say whether is it an extended packet one or a normal standard packet one. I say it is a standard by making it is extended ID is false. After doing it, I send that packet. That means the packet that I define every 500 milliseconds once, zero point 0.5 seconds once. I send that to, I periodically transmit that, right? Right. After transmitting it, if I get any reception from any other module, I just look for their messages. If I get any packets from any module, I will receive it. The moment I receive a packet, this callback is called. So I think for that, we have written a callback here. Uh, in Python can hotbyte implementation, they used to say like bus.receive and then a timeout. That's all. We additionally included a callback function. Whenever they receive a packet, this callback function will be called. So when it is called, we get a string, yeah, Python objects, that is message objects in the format of strings. Then I think in the format of series of bytes, we convert those bytes to string first. Then we convert that string to packet, can packet. After converting that to packet, we just print them on the screen, right? We just convert that packet to string and we print that in the screen. So that is what it happens here. So we get the packet in terms of bytes, we receive it, and then we convert that into string, then string to message object. Again, for the sake of printing, we convert that back to string again. Right. So in future, we use the converted packet object, that means message object, for various other reasons. That's why we convert that to message. Otherwise, we can just, after converting the bytes to string, we can print that. Why we have to convert that to object, message object, and then again converting back to string is not needed. But as we are going to use it in future for various other options, we are just converting it right now. Later, I will explain you what for we are doing it. So this is the code, that test code that we have to test our design, right? I told that I integrated RabbitMQ with the Python can library. So there should be some sort of proof for that, no? That's why we have this test program. When you write, the program is same. If you want to do the same with vector hardware or pecan hardware, just to go there and change the interface in can.ini file from RabbitMQ to their respective vendor. That's all. It will work for real hardware. Right now. That's all. So Now let us see whether this is working. For that, I'm going to run this program, right? I have a directory here under this. Let me show you what are the files that I have here. mytest.py, which is nothing but this Python program, right? And then I also have a ini file in that directory. Let me show you what I have in that. See here, this format is provided by Python can, Hotbyte Python can library developers. So you just have to mark your interface. This RabbitMQ interface is not available in their library. This is, we developed it. Right. Then RabbitMQ, you put RabbitMQ here and channel name is virtual can and set the bitrate. That's all. If you want to work with other real network analysis vendor, come here and change this interface to respective vendors like Vector, Pcan, like that. Right, that's all. Now it is ready. INI file is ready. Let me run the program now. Let us see whether it is running. Python can my test dot py. Right. See here, when we transmit a packet, we also receive it back because we do that via a same exchange so that whatever message that I am transmitting, that message will be received by the same node as well. Because in CAN network, every message that we have in our bus is known to all nodes right now. So it is actually transmitting a packet with ID 110. This is the bytes that we have in it, and it is again received by the same node, right? Then when they receive it, we have a direction as RX and the same byte that we receive, and we are seeing that in the trace. That's all. This is the implementation that we have. After doing this, after successfully achieving this, we started modifying our existing modules that we have, like BCM module, ICM module, ACC module, all those things one by one. We modified all of them. We migrated those code to Python can library based code. In that, let us see the BCM module that we have in our design, whether it is working fine or not. Like we migrated the code. Let me show the code and then we will execute it. So for that, first I have to terminate this. So now we are converting our code. We are standardizing our code to industry standard. That's all. Right here we have our, from this, I separated those implementation to a folder called Ehasia. Right here we have our module, which is based on Python can library. It's very simple now. So we used to have a packet definition, right? We declare a packet here and we assign the ID as 1/10. And with respect to data, we have only 1 byte because only vehicle speed we are going to have in BCM info. That's why I gave only 1 byte. And is it an extend ID is false, is RX is false. So all those things I did. After doing it, other things are same. See here, we don't have our transmit message, on message, routing, nothing. All those things are integrated to library now. Just by importing the library, you can get all those functions to work for you. See here, we just import can, And then from can import star, and then we import other things from that library only. That's all. But we don't have any function like transmit message, on message, those stuffs. Remaining things are just like an application code. The application code that is required for this module, uh, as based on the project requirement, right? No. So then let me run this program and see. See here, we transmit the packet BCM info every 250 milliseconds, and then we call for GUI, and we also waiting for incoming messages. See here, this is our BCM trace. So I change the speed value here. When I change the speed value, according to that, my X value of my speed is changed. Right now, this is a significant achievement that we made. This gives us a great area for improvement, and it is a great progress that achieved in this Python can training right now. So we are going to explore all these things further. As of now, we can stop here. Let me catch you with more detail in upcoming session. Thank you. Thank you for watching.